would rather receive Tiffany's gift?
Both.
Who would rather get Todd's gift? Why?
I already told you my reason. I already told you my reason.
Buy stuff like with the cash that you got, like at some store, and you could buy stuff online.
You'd rather shop online, so gift cards are better for you.
You can still use the card.
Gift cards expire and cash lasts forever.
You can still use the gift card.
You can't use it on Amazon. Amazon's on store.
You can't use cash on Amazon.
Yeah, you have to put it on the card and then put it.
Yes. Tiffany complains that the gifts aren't fair. Do we agree or disagree?
I disagree, but it's
Why do you disagree? Huh? Yeah, we don't know the value of those gift cards. Exactly. Okay, Tiffany's grandma says the gifts are worth the same. They have an equal value. So each gift card, we're assuming that each gift card has the same amount of money on it. What must the value of the gift card be? How'd you get there? 35. Oops. 30. Excuse me? Don't joke about that kind of stuff. 35 minus 20, right? That's the difference in their cash value, which is $15. And Tiffany got 2 gift cards. And the difference between gift cards would be 1, right? So that just means that 1 gift card, $15. Kind of similar to the rate of change that we were looking at, right? But there's another way to think about it. So $20 plus 2 gift cards. $20 plus 2, and then how do I write a value that is unknown? X. 20 plus 2x, that's Tiffany's. How would I write an expression for Todd's gift? 35 plus 1x, right? I'm going to solve this equation. Remember, to solve equations, I just get my variables on one side, numbers on the other side. So let's go ahead and move our 1x over here to be with their friend, the 2x. How do I move this 1x over here? Huh? Yeah, I subtract 1x. And these ones are going to cancel out. So 2x minus x gives me, 1x or just x. And then, let's move the 20 over here to the 35. So the opposite of adding 20 is just subtracting 20. Minus 20 minus 20. So x equals 15. Okay. You could also just guess and check, right? You could just plug in numbers to find out, but that could obviously take a long time, or no time at all if you guess on the first try. But okay, let's look at this next one. So Tiffany gets $25 and a box of candy, and Todd gets $20 plus 5 boxes of candy. Again, the grandma says she spent the same amount on both gifts. So what's the price of a box of candy? How'd you get there, Wyatt?
So 4 boxes is 25, or it's $5.
That's a good way, right? The difference between the cash is 25 minus 20, so that's $5. And then the difference between the boxes of candy is 5 minus 1, so it's 4. So we know that $5 is 4 boxes of candy, and then I just have to divide that to figure out what 1 box of candy is. So it would be $1.25 for 1. Good. Or again, can we set up an equation like we did in the last one and solve it? What would Tiffany's gift be as an expression? And then what's Todd's? 20 plus 5x, okay? And again, I want to get my variables all on one side, my numbers all on the other side. So what am I going to do? You want to subtract by 25? I'm going to subtract by 20. I want to subtract by 22 because if I subtract by 25, then I'm going to end up with a negative number, and I don't like negative numbers. So I'm going to subtract 20. Minus 20, minus 20. Subtracting 25 is not wrong. You'll still get to the same answer, but this is just a little easier. And we want to try and work smarter, not harder all the time, right? So 20 minus 20, that's 0. 25 minus 20 is? And now I'm going to move my x to be over here. How do I do that? Yeah, subtract 1x, subtract 1x. So 5 equals 5x minus 1x is 4x. And then we divide by 4, and I end up with 5/4 again, which is just equal to 1.25, right? Because you're never going to go to the grocery store and see something cost 5/4 of a dollar, right? We always write prices as a decimal. If you find a store that puts their prices in fractions, I would be really surprised. I don't believe it. Take a picture of it. Okay, what about this one? Tiffany got $15 in 2 pairs of socks, and Todd got $10 in 2 pairs of socks. Socks cost the same amount. Is it possible that their grandma spent the same amount of money on both gifts? Why not?
Because they say that their socks.
Yeah, exactly. So if I have, right, so Tiffany, I'm going to draw a little model for this. So Tiffany, huh? It doesn't, but I know that. It should have said that, really. No.
Like, I just said yes because she may have spent more on Tom's socks.
Right, and that's true. That's what everybody's been saying. Everyone's hating on Tiffany. So Tiffany got 2 pairs of socks, 2x plus $15. Todd got 2 pairs of socks as well, which we are assuming are is the same price, and then $10. These are never ever going to be equal because that would be like saying that 10 equals 15, but 10 never equals 15. It's always $5 more. So Tiffany was the one complaining, but she ended up getting the better gift. Okay, flip over to the other side. We've got a few notes to take. Okay. So, in order for an equation to be balanced, the difference in the constant terms must be made up for by the difference in the variable terms. Must be made up for in the difference in variable terms. In the variable terms. Makes more sense. in the variable terms. Okay. And the solution to an equation is the value of x that equalizes the expressions, that equalizes the two expressions. I just want to kind of give you an example of that first part. So in order for an equation to be balanced, the difference between constant terms must be made up for in the difference between variable terms. So if we look at, what did we have? 25 plus, what was it? No, 20. It was 20. Come on. Oh, geez. 20 plus 2x equals 35 plus x. So the difference in the constant terms must be made up for in the difference between the variable terms. What are my constant terms in this equation? No? In this equation up here. 20 and 35, my constants. 20 and 35. Whoops. What's the difference between those two numbers, 20 and 35? 15. So my difference between the constant terms is 15. And then what are my variable terms? 2x and x. And what's the difference between 2x and x? 2x minus x. 1x, or just x, right? So that tells me that x equals 15. Okay. All right, and then one more little example. So, yeah, to be honest, I had never knew that. I never thought about it in this way before. I just always solve it the other way. I don't know, by balancing, right? By doing like inverse operations. I've never thought about it this way, but I really like it. I think it's, I think it makes more sense when you're actually looking at real problems. It makes more sense that way. Yeah, no. It'll always be true. It'll always be true. And that's the thing is, so we've already talked about solving equations. We're talking about it today. We're talking about it tomorrow. And in Algebra 1, in Geometry, and in Algebra 2, in Pre-Calculus, in Calculus, any math class you take in high school, you're going to have to solve equations. And for different types of equations, you'd use different methods. For different problems, you use different methods. It's nice to just have all these tools in your toolbox, and then the more you practice, the more you learn, the better you'll be at being like, oh, this kind of problem would work really well with this method, versus a different kind of problem would work really well with inverse operations. And it's just having those different kind of tools. And then it also allows you to like check your work. Because if I do it this way and I get 15, then that's great. But then if I do it the other way as well and I get 15 again, I know more that I'm correct.
Some teachers that make you do have like two different equations or two different ways to do it.
I don't like that. I don't know. It's good to try out, and we're kind of focusing on one thing today and one thing tomorrow, but we all understand math in different ways, and I would never want you to conform to my way of thinking just because I think that way and I'm the teacher. Like, I'm no better than you because I'm a teacher or because I'm an adult. Like, we're just humans, and you're going to have to go through your life and experience math in whatever way you experience it and understand it in the ways that you understand it. So that's what you should be developing. You know what I mean? Not just doing what I tell you to do.
That's why I struggled so much in Dolores, because our math teacher just taught us one way and how she thought of it.
Yeah.
And we were doing this exact same stuff, and I was like, what am I even doing?
Yeah. Yeah. No, that's what a lot of people complain about in math is that, you know, and there's a million different ways to get to the same answer. Okay, but just one more example, and then you can do these problems. So if I have 7 plus 2x equals 3 plus 4x, I'm going to draw a little model of it. I actually have algebra tiles that we might play around with too. Okay, so 7 plus 2x, that's like this. I've got 7 here plus an x and an x. 7 plus 2x. And then equal to that is 3 plus 4x. So 3 is like a little less than half of 7. 3, and then I've got my 2 x's here, x and x, and then 2 more x's, right?
Yeah.
So again, I can look at just the difference between the constants and the variables. So I have up here, if this part right here is 3, then what would this part be? 4. So then that means that 4 equals 2x. So x equals 2. Or I could think about it the same way up here. You don't have to write this down if you don't want to, but my constants are 7 and 3, so the difference would be 4. My variables are 2x and 4x, so my difference would be 2x. So again, I get 4 equals 2x, so x equals 2, right? But I mean, and again, I would do it like the old school way, 7 plus 2x equals 3 plus 4x. I would just solve it like this, because that's how I learned it, and that's what makes sense to me. But again, I end up with the same thing, 4 equals 2x, so x equals 2. Okay. All right, you have 8 minutes to work on these 3 problems. We're not going to go through them today, so I just want you to do them on your own and then get it turned into the inbox. We'll probably go over them at the beginning of class tomorrow. So just try your best. 1, 2, and 3. Not today. So we're running.